It's also the most lethal. Here's the horrifying reality of traveling through a nebula. Welcome to the Purple Files. If you enjoy our videos, please consider subscribing to the channel. Let's get right into it. Science fiction has painted us a beautiful lie. We see our favorite starships gliding through majestic, swirling clouds of purple, pink, and blue. The journey's often depicted as a moment of cosmic wonder, a gentle passage through a celestial fog on the way to a new adventure. This portrayal could not be further from the horrifying truth. To enter a nebula is not to enter a gentle cloud, but to willingly fly into a multi-layered death trap, where the laws of physics conspire to annihilate you in the most terrifying ways imaginable. These stellar nurseries, the birthplaces of stars, are also cosmic tombs, and any vessel foolish enough to enter would find no escape, only a slow and agonizing end. Forget the fantasy. This is the reality. The first horror that would confront you is not a collision or an attack, but a creeping psychological dread born from the sheer, mind-taking scale of the void you have just entered. From our telescopes on Earth, a nebula looks like a dense, painterly object, a tangible cloud floating in the black. This is perhaps the greatest illusion in the cosmos. In reality, the vast majority of any nebula is a vacuum so profound it makes the space between planets look crowded. It is a vacuum far, far more empty than anything humanity has ever created in a laboratory. Let's try to put this into perspective. The air you are breathing right now, in a tiny volume the size of a sugar cube, contains roughly 5 quintillion atoms. If you were to take that same sugar cube and hold it inside the most advanced vacuum chamber on Earth, you might be able to reduce the number of atoms inside to a few 100,000. Now, take that sugar cube into the heart of a nebula. In many parts of that beautiful, glowing cloud, you would be lucky to find one single atom of hydrogen. One. The cloud is a ghostly suggestion, a whisper of matter spread thin over an impossible distance. The true horror of this is twofold. First, your journey is not a quick flight through a cosmic fog bank. It is a voyage across an incomprehensible emptiness that just happens to be slightly less empty than the interstellar void around it. The famous Orion Nebula, one of our closest cosmic neighbors, is over 24 light-years across. That is more than 140 trillion miles. To cross it in one of our fastest space probes would take well over 400,000 years. Even if you could travel at the speed of light, a feat of pure fantasy, it would still be a 24-year journey. You are not in a cloud, you are in a vast, empty region of space that stretches for trillions upon trillions of miles. The beautiful colors are just a thin, ghostly smear of atoms, a cosmic stain spread across an impossible canvas. You would be utterly, completely, and hopelessly lost in the largest and most deceptive void imaginable, a prisoner of distance itself. The psychological toll would be immense, a crushing agoraphobia, the maddening realization that you are fundamentally nowhere, adrift in an abyss from which there is no return. But this near-perfect void is not truly empty. And the infinitesimal amount of matter that is there is what will begin to kill you, not with a bang, but with a slow, grinding execution. This is the death by 1,000 cuts, a relentless assault from a cosmic sandblaster. The very same dust and gas that create the nebula's beautiful colors become a storm of microscopic bullets when you are traveling at any significant speed. These are not pebbles or rocks. Most are tiny grains of silicate, carbon, and ice, many smaller than the particles in cigarette smoke. But in space, speed is everything. The energy of an impact is calculated by 1/2 the mass times the velocity squared. This means that when your ship is moving at thousands or hundreds of thousands of miles per hour, that velocity term becomes enormous. At these speeds, a single grain of dust impacts your hull with the kinetic energy of a rifle bullet, and a nebula is filled with quadrillions of them. It would not be a single catastrophic impact. It would be a constant, unending storm, a high-frequency scream of tortured metal across the entire surface of your ship. Imagine the sound as quadrillions of microscopic impacts scour your vessel away, one atom at a time. First, your sensitive external instruments would go blind, your long-range sensors and communication arrays sandblasted into useless pitted metal. Then, your viewports, your only windows to the outside, would turn opaque, frosted over by a billion tiny cracks and fractures, plunging you and your crew into total claustrophobic darkness. Finally, the hull itself would begin to fail. The constant kinetic energy from the impacts would heat the metal, weaken its molecular structure, and slowly, methodically strip it away. Eventually, somewhere on the vast surface of the ship, a tiny pinprick hole would appear, then another and another. The ship would be slowly, unstoppably flayed by the very stardust it came to admire. And this doesn't even account for the larger particles, the pebble-size or fist-sized debris that also drifts within the cloud. Hitting one of those at relativistic speeds wouldn't be a slow grind. It would be an instantaneous, explosive decompression, turning your ship into a cloud of shrapnel to join the rest of the debris field. As your ship is being physically scoured out of existence, you and everyone aboard would be dying from a far faster and more insidious killer, the stellar death rays. Many nebulae, especially the most beautiful ones, are stellar nurseries. They are places where new stars are being born, and the newborns are absolute monsters. We are not talking about gentle, yellow suns like our own. We are talking about massive, young, hyper-energetic blue stars that burn with a ferocity that is difficult to comprehend. They live fast and die young, and while they live, they unleash a torrent of high-energy radiation, a constant lethal blast of gamma rays, X-rays, and hard ultraviolet light that floods every single corner of the nebula. Our own sun is a gentle candle compared to these stellar blast furnaces. A single large O-type star can be hundreds of thousands of times more luminous than our sun, and much of that energy is in the form of deadly radiation. This is not like getting a sunburn. This is a hard, sterilizing radiation, an absolute death sentence for any known form of life. Any astronaut unlucky enough to be directly exposed, even for a fraction of a second, would receive a dose so massive that their cellular structure would begin to break down almost instantly. But even deep inside the ship, you are not safe. Standard radiation shielding is designed to protect against the general background radiation of space or the occasional solar flare from a star like our own. It is simply not engineered to withstand a continuous, high-energy bath from a dozen nearby blue giant stars. The shielding would absorb the energy, but it would heat up, and eventually the sheer energy load would cause it to fail. Worse, the shielding itself can become a secondary radiator, absorbing high-energy gamma photons and re-emitting them as a shower of lower energy but still deadly particles inside the ship. Long before the hull is breached by dust, the ship's electronics would be destroyed. The delicate integrated circuits that run every critical system, navigation, life support, communications, engines, would be irrevocably fried by the intense ionization, turning your vessel into a dead, silent, radioactive coffin, tumbling helplessly through the irradiated gas. If, by some impossible miracle, your ship survives the sandblasting and the radiation, you must then contend with the gravitational nightmare. A nebula is not a uniform, peaceful cloud. It is a chaotic, lumpy, and gravitationally violent place. It is a churning cauldron of competing, invisible forces. Hidden within the glowing gas are countless objects that will kill you. There are thousands of protostars, dense, hot knots of gas that are in the process of collapsing to form new suns, each with its own powerful and growing gravity well. There are rogue planets, cast off from their own systems billions of years ago, wandering silently and darkly through the cloud. There are brown dwarfs, the so-called failed stars, which are incredibly massive but emit almost no light, making them virtually undetectable until you are already caught in their grip. And most terrifying of all, there are the ghosts, stellar mass black holes, the ancient invisible remnants of the giant stars that lived and died before the nebula even formed. their immense gravity still warping the space around them. Navigating this would be a complete and utter impossibility. You cannot see these objects. Your sensors, already being sandblasted, would be useless. Your ship would be tugged and pulled in a dozen different directions at once. A straight, predictable course is a navigational fantasy. Your journey would become a chaotic slalom through an invisible maze of gravitational traps. One minor miscalculation, one unseen brown dwarf, and your ship would be pulled from its course and dragged into an inescapable death spiral. You would be drawn in, slowly at first, then faster and faster, until your ship is torn apart by the extreme tidal forces, a process called spaghettification, where the ship and everyone in it would be stretched into a long, thin stream of atoms. Or you would simply be incinerated in the fires of a newborn star. There is no safe path. There is only a three-dimensional gravitational minefield stretching for light years in every direction, and every move you make is a gamble against annihilation. And finally, if you are somehow still alive, still functioning, you face the final crushing horror, being lost in a blinding, freezing fog. The very same gas and dust that is so thin up close is also perfectly, impenetrably opaque over long distances. Once you are deep inside the densest parts of the nebula, all points of reference would completely vanish. The light from distant stars and galaxies, the familiar constellations and galactic beacons that allow for navigation, would be completely blocked. You would be floating in a uniform, featureless glow of ionized hydrogen. There is no up, no down, no forward, no backward. You are lost in the most profound way imaginable, with no way to know where you are or which way you are going, imprisoned by a beautiful, glowing wall in every direction. At the very same time, your ship would be physically torn apart by a war of temperatures. The side of your vessel facing a nearby blue giant star would be superheated to hundreds or even thousands of degrees. The metal of the hull would glow red hot. Meanwhile, the side of your ship facing away, shrouded in the nebula's own shadow, would be plunged into the near absolute zero temperatures of deep space, becoming colder than liquid nitrogen. This extreme temperature difference across the hull, a gradient of thousands of degrees from one side of the ship to the other, would create unbearable mechanical stress. The hot side would expand while the cold side contracted. The ship's structure would groan, twist, and buckle under the strain, the sound of popping rivets and screaming metal echoing through the decks until, with a final catastrophic bang, the hull would rupture, tearing itself apart from this relentless thermal torment. So, when you look up at the breathtaking images from the James Webb Space Telescope, when you see the pillars of creation or the vibrant colors of the Orion Nebula, remember what you are truly seeing. You are not seeing a gentle, colorful cloud. You are seeing a place of unimaginable scale and deceptive emptiness. A cosmic sandblaster that strips metal down to its atom. You are seeing a cauldron of sterilizing, inescapable radiation, a chaotic maze of invisible gravity wells waiting to trap you, and a blinding, freezing fog that will tear your ship apart while you are hopelessly lost. These celestial masterpieces are not an invitation to explore. They are a profound and humbling warning, a declaration of the universe's violent power. They are the perfect example of a beauty that can only and should only ever be appreciated from a great and safe distance. They are, without a doubt, the most beautiful and the most horrifying tombs in the entire universe. And that is it. If you've enjoyed this video, please consider subscribing to the Purple Files, click the like button, and drop a comment down below. More videos to come, and until then, thanks for watching.